Okay, some more section 3.8, number 11, and the directions for number 11, actually 9 and 11. A particle moves along the x-axis so that its position at any time t greater than 0 is given by x as a function of t. Find the velocity at the indicated value of t. In this case, the value of t was 2. And my motion was described by the function x of x equals the inverse tangent of t, or I'm sorry, x as a function of t equals the inverse tangent of t. And we want to find the velocity of t equals 2. Remember, the derivative of the inverse tangent of x is just 1 over x squared, so this would be just 1 over t squared. So remember, the velocity at any time, the instantaneous velocity, is the derivative of the position function. So I take the derivative of this position function, and I'll get the velocity. And what's the derivative of this position function? 1 over 1 plus t squared. And we want to evaluate that at 2, when t is 2. So it's just going to be 1 over 1 plus 2 squared. 2 squared is 4. 1 plus 4 is 5, so it was just 1/5. So that was pretty straightforward. And then number 13. And here's number 13. And number 13, the directions were find the derivatives of y with respect to the appropriate variable. So we want to take the derivative of the inverse secant of 2s plus 1. And remember, the derivative of the inverse secant was just 1 over the absolute value of u. Well, it would be of x times the square root of x squared minus 1. But since it's a function, so we're going to apply the chain rule. It's going to be the derivative with respect to x of the inverse secant of u. So it's going to be 1 over the absolute value of u times the square root of u squared minus 1 times the derivative of u, because we do have a function now. So keep that in mind. We are dealing with a function here, chain rule. Okay. And what's the derivative of this function? 2s plus 1, just 2. So again, I just put this right in the formula. The derivative of y with respect to s, this was my general formula, but now it's with respect to s. So dy ds equals 1 over the absolute value of u, this is my u, 2s plus 1, times the square root of u squared minus 1, so this is my u squared, so it'd be 2s plus 1 squared minus 1, and then times the derivative du dx times the derivative of this, which is just 2. So there's your calculus. Now we have to simplify it because the answer doesn't really look like that. I can put the 2 over on top of the fraction. This absolute value stays the same, but I can actually square this out. So this is a binomial squared, so that's going to be 4s squared plus twice the product, which would be plus 4s plus 1 minus 1. And these numerical terms become 0. 1 minus 1 is 0. So we have this. Now I can factor a 4 out, and that's a perfect square, so this is going to help. So I can rewrite this as 4 times s squared minus s squared plus s under the radical. Everything else is the same. But then what's the square root of 4? That's 2. So we can bring that out. Or we could say that's the square root of 4 times the square root of s squared plus s, and then the square root of 4 is 2. We could just separate that up. Using the square root of a product as the product of the square roots. Either way, we're going to get this, and the 2 over 2 is 1. So there's your final answer. dy dx equals 1 over the absolute value of 2s plus 1 times the square root of s squared plus s. Oops. Get this up so you can see it, pardon me. There you go. So again, 2 over 2 is 1. So this is what we have. So again, not too bad.